So far we have only dealt with simple molecules that can be figured out with my first 3 videos on Lewis structures for covalent molecules. Well, we got a problem that we haven't solved yet, and that is what happens when we run out of electrons and we don't have enough to give all of the atoms 8 electrons. That's what we're about to find out. So here we have 2 molecules, both of which are going to run out of electrons, as you will see. So let's go ahead and look and see our first step. We're going to start the Lewis structure without the electrons, and that's going to leave us right here. Now, in order to take care of the little problem that I'm having with this particular system, let's just do over here. There, that's going to work. Now, you can see I have 2 oxygens and a carbon. The carbon is in the center because his electronegativity is the lowest. And you can look that up on a chart or just do it by the trends. And that we've talked about before. So let's go on. And the next thing we need to do is redraw that. And this time we're going to put in the bonding electrons. And the bonding electrons are going to be done with a stick. And we're having trouble with this doggone thing. Okay, there we go. Got it straightened out again. Now you can see the bonding electrons. And the next step, of course, is that we're going to have to figure out the numbers. So let's figure out the numbers and see what we come up with. And so when we figure out the numbers, we've got carbon here with 4 and oxygen with 12. And the 4 comes because carbon is in column 4. And column 4, everybody has 4 valence electrons. Oxygen is in column 6, and each oxygen has 6 valence electrons, but there's 2 of them, as we see here. And so 2 times 6 is 12. Add them up and we get 16. Now, we take that 16 and we subtract out our our bonding electrons that are here and here. And so that's a total of 2 here and 2 here is 4. So we're taking 4 away from 16 to see how many unshared, my UNSH means unshared, how many unshared electrons we have. And let's go ahead and see what our problem becomes. We're going to put those 12 out, and we'll try and prove our formula, our Lewis structure, after we put out the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, we put out all of our electrons, and now we're going to check the numbers. So when we go to check the numbers, we've got to, first of all, look and see, do we have everybody with 8 electrons? And maybe we need to check the total electrons, see if we got that right first. So do we have a total out here of 16? I submit to you that 2 plus 4, 2 is 4, then 6, 8, 10, 12, 14, 16. We have the right number. So we can check off our first guy. He's good. Now, let's check out our second guy. This second thing is, do we have the, oh, I'm sorry, clicked off the wrong one. Let's get this right. Here we are. So, that one is good, but I can tell you right now, number 1, we're not going to have 8 for everybody, because look, we got 2, 4, 6, 8 for this oxygen. We have 2, 4, 6, 8 for this oxygen. We think we're okay. But we look at carbon. Carbon is looking at 2 here, plus 2 here is only 4. He's short. What in the world do we do in a situation like this? We're going to force one or both of the oxygens to share. And so I'm going to remove those unshared electrons on the oxygen and make that oxygen share. And now carbon has 2 more electrons, and let's count it. We've got 2, 4, 6, so he's happier, but he's not all the way. Notice we don't have any more electrons to play with, so we got to do some sharing. So now oxygen has 2, lost this by accident. Yeah, this this actually has 4. 2, 4, 6, 8, 2, 4, 6, 8 for my oxygen on the right. And now if we do the same thing over on the left and we get rid of 2 of these electrons and make them share, look what happened. Carbon now has a total of 2, 4, 6, 8. Each oxygen has 2, 4, 6, 8. And the other oxygen, 2, 4, 6, and 8. So now we've got everybody with 8 electrons, and our first condition is met, and we didn't change the total number of electrons. And the total number of electrons, remember, is in this rule here. So this guy is still okay. We still have a total of 16 electrons. Now, let's go ahead and work out our next guy. Okay, I think I got my movement problem solved. Now, let's look at hydrocyanic acid. This guy is a fun one because he comes up short as well. Let's see what happens. First of all, we lay it out, just like we always do. And then the next thing we want to do is knit everything together. So now we take the bonding electrons and show them. And you can see we have a bond now between hydrogen and carbon and nitrogen. Now when we work out our numbers, here's how it looks. First of all, hydrogen brings in 1 electron because he's in column 1. Carbon brings in 4 electrons because he is in column 4, and nitrogen brings in 5 electrons because he's in column 5. So add that all up, we get 10. Now, how many electrons have we used up in these 2 bonds here? Okay, 2 for each, a total of 4. That's what this 4 is all about. And we're subtracting 4 from the 10 that we started out with. And this gives us our unshared electrons, just like we did above. Now, we have a total of 6 electrons to pass out. And watch what happens. First off, we can't put anything on hydrogen, because hydrogen already has 2 with that bond between him and carbon. But we can put 1, 2 here on the carbon, 3, 4 here on the carbon, and then 5, 6, and I'm done. Well, carbon is happy. See, carbon has a total. Let's work out our totals for each atom. And carbon now has a total of 8 electrons. And he's got 2 unshared pairs for a total of 4, plus 2 shared pairs for a total of another 4. So he has 8. But nitrogen, poor guy, he's only got 2 in the bond and 1 pair for himself, and that's not enough. That gives him 4. So we fail on our first rule. So I'd like you to stop the video and see if you can think of what you could do to make this work. So let's go ahead and see what you did. I'm going to tell you right now, we got to make this carbon share. I hope that was your idea. And because carbon has to share, we don't want to get rid of those 2 electrons, but we want to put them into a bond. And now carbon has 2 more. Guess what we're going to have to do, because nitrogen is only left with 6. See, nitrogen here, we've got 2, 4, 6. Carbon still has 2, 4, 6, 8. So we're going to make carbon share that pair up there as well. And guess what happens? We wind up with the right number of electrons for everybody. And so let's check it off. We've got 8 for nitrogen, and that gives us the 2 here, 4, 6, and 8. And carbon has 2, 4, 6, 8. And hydrogen has 2 in the bond. So everybody has the right number of electrons. Remember, hydrogen is one of those that is an exception. He doesn't want 8, and that says it up here in our little chart in the top right-hand corner. Hydrogen, beryllium, and boron are exceptions. So everybody else has 8. So we're good there. Now, do we have a total of 10. See, our total here was 10. And so what we're going to do now is count the total number of electrons. 2, 4, 6, 8, 10. Yes, our total is correct. And we have completed a successful Lewis structure for 2 different molecules, each of which was short electrons and wound up having to share their electrons to make the Lewis structure work properly. Hope you find this helps.